Chapter 14, number 64. A string that is 2.5 meters long with a mass of 3.6 grams is stretched between two fixed points with a tension of 91 newtons. Find the frequency of the fundamental on this string. So remember that if this is our string sort of at rest, the fundamental is when it's like this, and we know that the wavelength of the fundamental is twice the length of the string, and therefore the frequency on the fundamental is the velocity divided by twice the length of the string. And that's a bit tricky because we don't have the wave speed, but we can get it pretty easily because we know that the wave speed is the same as square root of the tension over the linear mass density. And the linear mass density is just the mass per unit length. So we have 2.5, we've got 3.6 grams divided by 2.5 meters. We've got to multiply the grams by, of course, 1 kilogram per 1,000 grams. And that gives us a mass per unit length, a linear mass density of 0.00144 kilogram per meter. Really, though, we only have two digits here, so 0.0014 kilograms per meter. And that means that going back over to here, our wave speed is the 91 newtons over 0.00144 kilograms per meter. I'm keeping the extra digit of accuracy because we're doing calculations and we want to only throw it at the end. 91 over 0.00144 gives me a wave speed of 251.38 meters per second, which is really 250 meters per second. And then finally, we can go all the way back over to here and say that we have 250 meters per second over 2 times 2.5 meters. And so we get 250 over 2 times 2.5, which is just 50 hertz.